Okay, in this video I'm going to be talking about how to convert from one metric unit to another metric unit. Um, it's important to keep in mind that we only really convert between one type of unit, so from meters to meters, or liters to liters, or kilograms to milligrams, or whatever. Just because the other ones aren't necessarily compatible unless you know some rate at how they convert. Okay. Now with metric ones, you can convert milliliters and meters and stuff like that, because those are all units of volume is related to units of length, which is what we're going to do in a future lesson. But unless you knew unit mass, you wouldn't be able to convert necessarily from volume to mass, and converting from length to mass wouldn't make any sense. So we just basically convert from one type of thing to the same type. Alright, now I haven't included the table of different types of things just because it's not really relevant to this topic. What we're really concerned about is looking at the modifiers, so giga, mega, kilo, and all the rest, and how they are related to powers of 10. So I'm going to do this by example. I'm going to show you two different ways to do this, one using a number line and the other one using a technique called unit analysis. So let's get to it. Okay, so let's say, for instance, I wanted to convert, let's say, 27 gigameters, that's 27 billion meters, to its equivalent in millimeters. Okay, so if that's my question, what I could do is start off with a number line. Okay, and what I'm going to do is compare the relative magnitudes of giga with milli. Okay, so millimeters are here, millis, and that means 10 to the negative 3. Okay, and I can get that from looking at my chart here. So milli is 10 to the negative 3, and while I'm here, giga is 10 to the 9. Okay, so giga is over here at 10 to the 9. Okay, and what I can find is, well, how many magnitudes are there between this? Okay, and what I would see is that there is a magnitude of 10 to the 12 from here to there. Right, so in order to get from milli to giga, you would have to multiply by 10 to the 12. Alright, and in order to get from giga to milli, you would have to you'd have to divide the exponent. Okay, so what we're going to do here is I'm going to say, well, if I have 27 gigameters, okay, well, now I have to decide if I'm going to multiply or if I'm going to divide. Okay, and what I'm going to do is I'm going to multiply, and I'll explain why in just a moment. So times 10 to the 12. Okay, it makes sense that I'm multiplying because I should get more of them, right? If I have 27 billion and I want to find out how many of these really tiny units there are, then I should get more of them, right? Okay, that's going to be equal to 27 with 12 zeros after it. Okay, so 1, 2, 3, 4, 5, 6. I'll put a comma in between them. 7, 8, 9, 10, 11, 12. So 27 with 12 zeros after it. Now normally we wouldn't express an answer like this. Instead we'd use scientific notation. So that would be 2.7. And what I'd do is I'd go back and say, like, well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 place values. So times 10 to the 13 millimeters. Okay, and that's how you could use a number line to do this. Okay, so it's important to note some of the key things here. One is just looking at the magnitude of 10 that stands between these two values, and the other one is to know whether you should multiply or divide. As a basic rule, when you're going from bigger or smaller, or bigger to smaller, you should be multiplying, and when you're going from smaller to bigger, you're going to divide. Okay, let's do another example, and then I'll show you another technique. Okay, the second example I have is, let's say, 8,954 centimeters. And what I want to do is I want to say, well, how many kilometers is that? It's blank kilometers. Okay, again, I can use a number line to do this. Okay, and I say, okay, well, where's centimeters on here? Let's say it's just over here. So centimeters is over here, and that's 10 to the negative 2. Okay, if I go back to here, centi is 10 to the negative 2, and I'm going to kilometers, so that's 10 to the 3. Okay, so I go to kilometers over here, which is 10 to the 3. Well, how many magnitudes of 10 are there between there? Well, there is from negative 2 to positive 3, there is 10 to the 5. Okay? Alright, so then if I have 8,954 centimeters, okay, is equal to, and now what I'm going to have to do is divide by, so 8,954 divided by 10 to the 5. Okay, so divided by 10,000. Okay, or sorry, 100,000. Okay, I'm going to get 8,954. I should just write it like this. 8,954. Okay, so divided by 10 to the 5 is going to be 1, 2, 3, 4, 5. Okay, so I just move the decimal over 5 spots, and that's what I have. Okay, so kilometers. Okay, and so what I would get there is 8.954 times 10 to the negative 2 kilometers. Okay, and that's the answer for that one. Alright, now I should say I personally don't really like using this method because it seems a bit odd to me, and it seems a bit confusing, or that you could easily get confused remembering whether you should divide or multiply or things like that. So I personally don't like to use this, and I never use this myself. But if it makes sense to you, and if you want to use it, then feel free to go ahead. You're still going to get the right answers from it. Instead, what I prefer to use is a method called unit analysis. Okay, so I'll just write that here. Okay, so unit analysis. Okay, with unit analysis, it's important to know that when you're doing mathematical operations, you can do those operations on the unit as well as the number. All right. So, for instance, when I express a speed, for instance, as like say 35 kilometers per hour. Well, why is the unit kilometers per hour? Well, it's because the general equation for finding a speed, we'll say s, is equal to distance over time. Okay, and distance is measured, let's say, in kilometers, and the time is measured in hours. So that the speed is measured in kilometers per hour. Okay, so the unit that you're measuring it in comes from that, comes from the equation. Okay, and we can take advantage of this fact by looking at where units come from and related rates of units. So let's say, for instance, I wanted to do 326 milliliters, and I wanted to find out how many liters were in there. Okay, well, what I could do is I could say, well, I'm going to start off with my 326 milliliters, and what I'm going to do is multiply it by a rate. Okay, so what I'm going to do is say, well, there's 1,000 milliliters in 1 liter. Okay, now in order to know how to set this up, what you have to know is, well, you may ask, for instance, how come I didn't flip these? Well, what I want is to recognize that the units can be multiplied or divided as well. And so what I have here is milliliters divided by milliliters. Okay, and so milliliters will cancel out with the milliliters down here. Okay, they'll divide out, and the unit that I'll be left with is liters. Okay, so in this case I would get 0.326 liters. okay, or better expressed as 3.26 times 10 to the negative 1 liters. Alright? Now, the biggest mistake that I make, and probably other people will make as well, is that they will make a mistake on the conversion. So they might say something like this, times 1,000 liters per 1 milliliter. Okay, which is just simply not correct. And just got to be careful not to make that mistake. Alright, let's do another unit analysis question, and this will be the last one I'm doing for this example, or for this video here. Okay, so let's go one that's a little bit more difficult. So 2.5 kilograms. And what I want to say is, well, how many milligrams does that equal? Okay, so now we're doing it in 2 steps. Okay, so what I'm going to say is, well, this is 2.5 kilograms. And I need to get from kilograms to milligrams. Okay, so I need to get from kilograms down to milligrams here. And it might not be readily visible how many magnitudes there are between there. So what I can do is go from kilo down to the base unit, okay, which is 10 to the power of 3, which is 1,000 times. And then I can go from the base unit down to milli, which is another unit, magnitude of 3. So there's 1,000 kilograms per gram, and then there's 1,000 milligrams in 1 gram as well, or sorry, 1,000 grams in 1 kilogram, and 1,000 milligrams in 1 gram. Okay, so let's take a look at how this would work. Okay, so 2.5 kilograms times, now we have, as I said, 1,000 grams in 1 kilogram. Okay, now what that would mean is these kilograms cancel out. Okay, but now I have my answer expressed as grams. Okay, and so what I need, I don't really want it in grams, I want it in milligrams. So I'm going to introduce another rate. Okay, and I have 1,000 milligrams per 1 gram. Okay, and the grams will cancel out. And once again, if you're careful with the units, you should know where they should go, either on the numerator or the denominator position, because they need to cancel each other out. Okay, so in this case, I have 2.5 times 1,000 times 1,000. So this is 2.5 times 1,000 would be 3 place values over. Okay, so 0, 0. And then times another 1,000 would be another 3 place values over. Okay, so this would be equal to 25 or 2.5 million. Okay, so this is milligrams. And again, we don't express big numbers in this way. So what we do is we say 2.5 times 10 to the 6. If I'm correct, it's 1, 2, 3, 4, 5, 6, yep, milligrams. Okay, and that would be my answer. Okay, hopefully this video is helpful to you. I'm going to be posting another video shortly on how to convert from the imperial system to the metric system, and back and forth, and then the following video we'll be talking about areas and volumes. So if you have any questions, give me a shout, drop me a line, or send an email or comment on this video, and I'll try and help you as best I can.